This research focuses on assessing human motion through the use of wireless sensors by identifying and analyzing the consistency and accuracy of assemblies performed to achieve the goal of improving the effectiveness of training in the manufacturing industry. My name is Jonathan Ellison, and I have worked in conjunction with Dr. Rahul Renu to create a metric that can evaluate the consistency and accuracy of assemblies based on the linear acceleration data received from smartwatches that contain IMUs or inertial measurement units. The data provided from the smartwatches is analyzed through the STOMP algorithm, which can identify motifs or repeated instances in a time series from which the assembly cycle can be determined. Then, using these cycles, the consistency and accuracy of the assemblies can be determined using the principles of Euclidean distance and the working equations shown in the results section. These working equations for consistency and accuracy are subject to a greater than zero constraint, as the value of zero in the data indicates that no work is being performed in the assembly. So for a time series of length m, the accuracy of the assembly is found by taking the difference of the Euclidean distance between the ideal and trial assembly divided by the Euclidean distance between the ideal and horizontal axis at each point. Then summing these values and subtracting the result from 1 and representing it as a percent to get the accuracy of the assemblies. Similarly, consistency is found using the same process as accuracy, except you are essentially taking the accuracy of each assembly with its predecessor, then taking the average accuracy and subtracting that result from 1. They're representing that value as a percent to get the consistency of the assemblies performed. For these equations to work as intended, the time series needs to be adjusted to match in time as closely as possible for both the ideal and trial assemblies. And outside of this condition, a dynamic time warping method would have to be applied to get the desired results from the equations. And while this is still an emerging field of research, the future plans entail establishing a concrete equation and definition for consistency and accuracy to be used in testing, and determining the efficacy of these definitions for real-world applications, while also finding a way to implement these equations into code so that it can quickly return a value for consistency and accuracy and be used by all levels of the manufacturing environment as a way to monitor, control, and enhance the current training methods.